Hello, seniors. This is your Algebra 2 semester exam. Please make sure you write your name, the date, and the period of which you are taking this test on the front page of this exam. As you take this test, please make sure you use the pause button. If you're listening to this, after I read a question, hit pause, work it out, and then hit play again to move on to the next question. If you have any questions, please contact your local educator. Thank you for listening and good luck. Okay guys, here's question number 1. Remember, you can use your notes on this as well. What is the vertex of the graph? Y equals x squared minus 10x plus 27. May be helpful for you to remember to use negative b over 2a. Okay, that might help you find the x part of the coordinates. Okay, so again, use this to help you determine. If you find the x, pretty good chance you might just be able to use the y. Find out the y. Plug it back in. On number 2, what is the correct factorization of x squared minus 6x minus 27? Okay, when we factor, it could be helpful to use the ACB chart. Okay, remember your A here is probably going to be 1, the B is negative 6, your C is negative 27. Use that to help determine what your factors and what their signs should look like. Make sure you write your answer on the test and as you put it in on Socrative. Again, hit the pause button if you need to as we work. On number 3, it's the same thing as number 2. The only difference is we have a little different number out in front, so you're going to want to use this ACB chart. Okay, take A times C, all right, and make sure then together they would combine to get B down there. And then you can use the box if you want to help factor. Remember, first box, first term, so 12x squared. Last box, last term. Okay, and these boxes here, it's going to be whatever these factors are that you get. And then pull out the term here, 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 and here. And that'll tell you what goes in your parentheses. Okay, good luck. On number 4, what are the solutions of the equation y squared minus 11y plus 30 equals 0? All you got to do is plug in the values and see which ones work out. Just plug and chug. Number 5, similar to the last problem, want to figure out which set of values, okay, are going to be able to satisfy this equation, 10x squared plus 1x minus 2 equals 0. All you got to do again is plug one number in for x squared, the other number in for x, work it out. Figure out which one works. Number 6, what are the solutions of the equation x squared plus 5 equals 32? Again, you could just plug each of these values for f, g, h, and j in for x and see which one works out. Use your notes. Don't forget, you can use your notes. That's number 6. Number 7, what are the solutions of x squared minus 14x plus 49 equals 48? Now, I believe what you want to do is make sure we try to move this 48 over to the other side first and set it all equal to 0. And then again, you can you got to factor this out. Okay, factor it out and solve and see which one works. Use your notes. On number 8, write the set 3 plus 2i minus the set 4 minus 3i in standard form. Don't forget, you're going to want to kind of distribute that negative in first and then combine your like terms. But one thing I want to caution you is remember, I squared, okay, is the same thing as negative 1. Okay, I squared equals negative 1. Number 9, you need to write this in standard form. The only difference from this one is that it's multiplication. So you want to FOIL, remember FOIL. Okay, first, outer, inner, last. Remember what we talked about on number 8 as far as I squared equaling negative 1. Okay? On number 10, what is the vertex form of y equals x squared plus 8x plus 10? Again, you want to kind of look at your values listed here. They'll help guide you in the right direction. Use your notes. Okay? That's number 10. On number 11, what are the solutions of x squared plus 6x plus 10? Again, you could factor this out and, factor it out into two sets, x something, blank, blank, and then set each one equal to 0, and then it could help figure out your solutions. That's number 11. Okay, number 13 says for the function y equals negative x squared minus 6x minus 7, you need to find a vertex and the axis of symmetry. All right, an easy way to go about this is, again, use that negative b over 2a. That can give you the x. All right, you've got 4 different choices listed right here for x, so basically you can find the x, kind of takes care of the rest of the problem for you. Okay, as we jump down to number 15, what is the vertex of the graph of the function y equals 2 times the set x minus 4, that set squared, plus 6? If you use your notes, remember, we want to key in on these two guys right here. You got to do something with the signs, all right, to help figure out what is the vertex of the function. Remember, your function, it's going to look something like this. What's the vertex point there? That's what we're looking for. Number 16, what is the vertex of y equals negative 3 times a set x minus 2 squared minus 4? Same concept as 15. Okay, you need to really take a look at these numbers here. Use your notes. Hopefully you took good notes. On number 18, you're to factor this expression, m squared minus 4m minus 21. Okay, and actually, if you want a hint, you could FOIL all of these, all 4 answers A, B, C, and D, and it should give you that answer up there. It's a good, easy way to kind of, not necessarily cheat, but work backwards. On number 20, what are the roots of the equation z squared plus 11z minus 42 equals 0? Basically, you want to factor this whole thing out. So get it into 2 sets and then set it equal to 0. And then solve each one as its own equation. That'll tell you what the roots are for number 20. On number 21, again, you have to factor. The difference here is that there is a common number that needs to be pulled out of 8, 28, and 12. And then factor it so you're going to get a set looking like that. So you figure out which one of these would be your common term, your greatest common factor, and then make your ACB chart and factor it out from there. Okay, 23, a little plug and chug here. What are the solutions of the equation w squared equals negative 9w? Again, plug one in for one of the w's, one in for the other, work them back and forth, try to figure out what makes it equal on each side. Number 25, what are the solutions for negative 3 minus 1 y squared equals 24. You just got to solve for y here, but just be real careful. Remember, that's a negative 1, and that is going to severely impact your answer in the end, okay? So work that out. Move the 3, get rid of the negative 1, then take the square roots of both sides. See where that gets you. Remember, please remember, negative 1 is the same thing as I squared. Number 27, what is the standard form of the expression? The set 4 plus 3i plus negative 1 minus 6i. All we got to do is kind of bring this group and put it underneath like this. Okay, combine your like terms then, okay, and add down. Number 28, what are the solutions for negative x squared plus 3x minus 3 equals 0? I would factor that out if I were you, okay? But again, by factoring it out, put it in a couple sets, equals 0. Take that route there. Number 29, what are the solutions for negative 2x squared minus 4x plus 4 equals 0? Again, factor, but pay attention. Look at your numbers. It looks like there's a GCF that can be factored out first. All right. Then make up your two sets. Set them equal to 0. Number 32, what is a simplified form of 8a squared plus 8a squared bc to the negative first over 12ab to the third c? One thing I want to really remind you of is these guys all have their own power if there's nothing one given to them. And remember, if somebody is not happy, they need to move, okay? And then also, pay attention to the fact that you've got numbers that could reduce in the end, okay? So take a good look at that, be careful, follow your notes. Hopefully you took good notes. That's number 32. Number 33, what is the simplified form of this whole set over here? I'm not going to try to read all that to you. You can see it. But one thing, again, I want to remind you of, let's bring this guy in a little closer, is that if it's power to a power, these guys are being raised to the fifth. So you got to multiply. That x has got a power of 1, y a power of 4. And this is actually going to be raised, both of those to the negative 1, and then raise that again to the fifth power. Be real careful. There's a lot of work here to work out and show. Okay? Work off to the side. If you use another sheet of paper, that's fine, but make sure you hand that in with your test. That's number 33. 34, you need to multiply these two numbers together and write them in scientific notation. Remember, there's a real basic rule with scientific notation as to how the first number is to look. Okay, how this first number here, they're to look a certain way. All right, calculator should be able to help you out a lot on this one. Okay, number 35, which polynomial function is graphed below? So you got to look at this graph right here, and which of these match up with this. Here's what I would do. I'd get on Desmos on your graphic calculator on the Chromebook and plug each one of these in and see which one looks like him right there. That's 35. On number 36, the question is, what is the degree of the polynomial? So remember, when we're talking about degrees, I think you're wanting to look at these little people, these exponents, okay? You should know what that is. That's 36. On 37, we want to know if we simplify this whole expression, what do we get? And remember, you probably need to distribute that negative to everybody first, and then stack the two sets of terms up on top of each other, and then combine like terms going down, okay? So get the squareds with the squareds, and the x's with the x's, and the whole numbers with the whole numbers. But I'd stack them top and bottom. That's 37. Number 38, second verse, same as the first. It's just like 37, same concept. Distribute this negative into everybody first, okay? And just be real careful with your signs. Take a notice, though, you've got a cubed term here, but not on this other side. So if, for example, like when I'm going to write them, I'm going to stack them up. I don't have a cubed term, so I just put a 0 there. And notice you don't have a squared term on the right, but you do on the left. So just add zeros to kind of make space so everybody fits into a column somewhere. That's 38. Okay, number 39, we need to complete the factorization. So you want to look for your common terms here that you can pull out. As you can see, all these guys that are lined up here out in front, right there, okay? And then what are you left with on the inside of the parenthesis? That's all you got to do. 41, what's the maximum number of turning points for this function? As you're taking a look at this, use your notes. You know, you could also use the Desmos on the graphic calculator. I just did it on mine. Plug that whole thing right in. Tells you how many turning points you'll have in a graph. Number 42, again, we're asking for the maximum number of turning points in this function. I'd just plug it all in the graphic calculator and just count. Is it 3, 4, 5, or 6 times that it turns? Have fun. On number 43, you need to simplify this here. And remember that 3's got a power of 1, and then this is going to all those other guys right there. Power to power means you multiply. And remember, if you've got an unhappy wife, you got 2 to the negative second power, she wants to leave and go live somewhere else. Don't forget that rule about the powers. That's number 43. Okay, here's an observation problem. Which cubic, okay, cubic being the key word here, has a function has a leading coefficient of 1. So take a look at which one of these F, G, H, or J is a cubic, and then which one has a leading coefficient of 1. Look at them very carefully. Okay, 45. Which statement about the end behavior for this function is true? Use that box that was in your notes. I'm sure it's on there about end behavior, and just read through all of these very carefully. Look at your signs, look at the exponents, everything that's required, and that'll lead you down the right path for number 45. On number 46, we've got another difference problem. Again, we need to make sure you distribute that negative into everybody first. Stack them up on top of each other, put him underneath that one. Line up the powers in the correct order, and then combine all the like terms going down and simplify. On number 47, we want to know what is the product when we multiply these two terms together. If it were me, this is what I would do for this problem here. Let me kind of shrink this and get it out of the way. All right. All I would do is I would make the table. This is me. If you don't like it, do it the other way. Just kind of multiply them through. But I'd put the x plus 5 over here, and then the x cubed negative 2x minus 3 here. And then just start multiplying like I'm going to get x to the 4th there. And you just keep going, multiplying these out. Okay, combine all your like terms in the end. All right, and you should be able to find your answer that way. Number 48, what is a quotient? So you got to use long division. Okay, again, let me kind of shrink this off to the side here and we'll kind of talk about it. Okay, so on the outside we've got x minus 2. Inside the box we're going to have x cubed minus 3x squared plus 4x minus 6. Remember the steps, and you should have those in your notes, but we want to match this first term. So for example, just to get you going, I've got an x to the first here, so I'm going to put x squared up here because you add the powers, that gives me the x cubed, and then you go negative 2 times x squared, and I'm going to get a negative 2x squared. Okay? So remember then you got to change the signs. That cancels these two out, which is what you want. And then you add down over here on the right, and you're going to have a negative 1x squared. Then drop your next term, positive 4x. And then you do the same thing, following the same steps. That is number 48. On number 49, which polynomial has the factorization x minus 10 times the set x squared plus 10x plus 100. Which one seems right? I just kind of multiply them out there. That's all you got to do. 50, little plug and chug. What are the solutions? If you have x to the 5th and negative 5x cubed equals 36x. Probably going to need to move that 36x over in order to start factoring all that out. Number 51, what are the solutions of 2x cubed plus 4x squared minus 20x equals 10x plus 60? Get all your like terms together. Get them all on one side get it set equal to 0, and then factor things out. And then set each of those equal to 0. Okay, remember when you're factoring, if there's a GCF, pull that out first. 52, hey, back to turning points of a function. So all you got to do is plug that into your graphic calculator. How many times does it turn? 2, 3, 4, or 5? Okay, 55, you want to simplify this expression, 4x to the fourth times y, all raised to the 3/2 power. Okay, let's assume all the variables are positive. So again, you want to remember, we'll kind of zoom out here briefly. And actually, we'll work it over here. So just so you see, so you got 4, then he's to the first power, then x to the fourth y, and that's all being raised to the 3/2 power. So you just got to distribute that 3/2 to everybody, and that y's got a power of 1 too. Okay. If you're not sure, use your calculator. Take 1 times 3/2, 4 times 3/2. Okay. And then you should be able to simplify from there. Okay, on 56, again, we're simplifying. You've got some terms down here with fractions for powers. And then remember, when you've got, x is on the top and x is on the bottom, remember, these two guys are going to have a little fight. Who's going to win? It's the top, and he's left with just a power of 1. It's kind of the concept you want to go with when we're doing division here. Okay, 57, we want to know what the solution is, so you got to solve. Again, I'd add 7 first, and then divide by 5, and then remember, if you want to get rid of x to 2/3, that means you got to raise it to the 3/2 power. And of course, it's the equation. What we do on the left side, we got to do to the right. So take your time and work that out carefully on 57. Number 58, we're doing some function work here. What is the function, or what is f minus g? So here's f, here's g. So plug that in for f minus g. It's going to look a little something like this, like 3x plus 2, that set, minus this set. That's the g. Okay? So maybe distribute that negative, and then combine all your like terms and see what you get for 58. 59, same concept. We've got two functions here. It's just they've written it out a little bit different. So start from the middle out. So you're going to take at x plus 4, okay, for g, and then it's going to be multiplied by, everywhere you see the g function, you're going to plug this in for the x. Oops, I don't need that. Whoopsie daisy. There we go. Okay. So instead of x squared minus 2, you're going to have x plus 4. That's the g. And he's going to be squared. And then minus 2. You kind of finish that off. Okay, that's 59. Number 60, what is the inverse function? Function of 8x cubed minus 7. Follow your notes. Those are pretty detailed and kind of tell you what the inverse of that should be. Okay, just do some observation on that one. Okay, number 61, what is the value of 32 to the 3/5 power? Just plug it in the calculator and work it out. Number 62, what is the solution for 2x to the 5th equals negative 64? Just like solving an equation, get rid of the 2, and then remember, if you want to get rid of that x to the 5th, you're going to have to take like the 5th root of it. Or you could say it'd be like saying x to the 1/5 power, just flip it upside down. Number 63, which expression is in simplest form? All right, so just kind of combine your like terms. You could probably plug it right into the calculator. Number 64, again, just simplify this. Okay, pay attention. You got a negative 1/9 power on the outside. Take everything to the power first. And then remember, if it's not happy, if it's a negative power, they need to be moved to the bottom or moved to the top, wherever they're at. Again, calculators should be very helpful on this one. Okay, 65, assuming all the variables are positive, what is the simplified form? Use your notes, follow the directions on what guidance of what you're to do when you have these radicals. Okay, and which one is simplified for 65? 66, you're to solve this. What are the solution or solutions? And remember what the rules are. If we want to get rid of this radical, you got to square it, but what you do to one side, got to do the other. All right, that should get you going as to solving the rest of it out for x. 67, what are the solutions? Again, got to get rid of the radicals. Similar concept as what we did on the last one. If it's just a regular square root, you can just square everything else. That's 67. 68, we're back to simplifying some functions. Okay, so what is the function of g of f of x? So everywhere we see the g instead of 2x right here, we're going to plug in the 3x squared. Okay, similar to the one we did earlier. On number 69, another function, they're wanting to say if you take f minus g, what do you get? So here's your two functions. Here's f, here's g. Subtract them. Subtract those sets. Okay? Make sure you pay attention to the signs first. Okay? Remember, you're going to take the whole set minus the other one. So you'd want to distribute the negative into everybody there. Okay? Good luck. Number 70, what is the inverse of y equals 10x minus 2? Again, follow your rules and your cues and your notes for the inverse. 70, again, what is the inverse of h of t for the function of g of t, which is a negative 8 over 27t cubed? What is the inverse? You got 4 choices there. Take your time. Use your notes. Okay, as we get to 72, I feel like we're sliding downhill trying to read this question. Okay, so the graph of y equals radical x is shifted 2 units up and 3 units left. Which is the equation translated in of the function? I'd use a graphic calculator even to help you with this if you wanted to. Hey, back to the graphic calculator here on this 73. You got a function, okay, he's kind of going right through there, okay, and there's a point there. So which of these equations, A, B, C, or D, is that a graph of? I'd use Desmos. Use your graphic calculator. Okay, last one. What is the domain for the function of x is equal to the cube root of x plus 1 plus 3? What is the domain? So, all you got to do is solve it out. Plug it in your graphic calculator if you want. Find the x values. That is your domain. Hey folks, now that you've answered number 74, check and make sure you've answered all the questions. Put in your answers into Socrative. Make sure your name's on your paper. Also make sure you have answered and marked your answers on the page as well. If something happens on the computer, then we've got it on the paper to verify what you answered. Hope you enjoyed this exam. Hope you enjoyed listening. Thanks for tuning in. We'll catch you next time, because another one bites the dust.
Another one bites the dust. Another one bites the dust. And another one